So the next thing we're going to learn how to do is how to run a Docker container non-interactively. So far we've been running our containers interactively, but sometimes we want to automate things further and run things in the non-interactive mode. We do this by dropping the -it flag from our Docker run command when we're running things in the bash, and then at the very end of this call we add a command or a script call after the Docker image is specified. The general form for doing this non-interactively is as follows. So we have Docker and then run. Then we have --rm to make the container ephemeral. We don't put -it. If you need to mount volumes, you do the regular thing for mounting volumes here. Oops, we should stop here. And then you have to specify the Docker image that you'd like to run. And usually that's where we stop with our Docker run commands. But here, to run things non-interactively, we add additional commands or script calls after the Docker image. So we'd say something like program to run, like Python, and then program arguments like download data.py and the other arguments that that script would take. When you did something like that, what would happen is the Docker container would open up, execute the script, and then close back down again. And you won't be interacting with things when that's happening. So let's go through a simple example where we're going to use the container that we just built on GitHub Actions and published on Docker Hub to non-interactively run some R code. So we're going to start with Docker run. We're going to skip --it, but we will use -rm. And then we're going to say the name of the Docker image, which is going to be ttimbers Dockerfile practice. And then why don't we be very good and we will specify the specific version of that image as well. And then we're going to run an R script. We're going to say R script -e. And we're going to take advantage of the cowsay package. And we're going to say snow this week. And we will have a cute little snowman asking that question. So let's see what happens when we do this with dropping the -it flag. And again, I didn't mount the volume here because we're just running a command from R that we don't need any of the files on our local laptop to do. And then we get a cute little snowman. But the point of this was that we were able to run this command interactively. So this is different than what we did before. Before we did Docker run -it, and so that would open up a container, and we'd be able to like ls, cd, pwd, make all, do a bunch of commands inside of it. Here, we're saying container, run this command, and then shut back down again. And that's what's happening. Okay, so that was a silly example. But this can be made powerful so that we can run an analysis pipeline like make non-interactively. So we're going to do it. I'm going to do a short demonstration now. So I provided you here a link if you'd like to follow along to download the data analysis pipeline project that we've been kind of working over on the last couple of lectures. And it now has a Docker file in there, and that's also been created on Docker Hub. And we're going to run essentially this command here, which is very similar to what we just did, to run it non-interactively. One thing to think about while we're doing this is typically we run make all, but when we enter the container, we don't necessarily end up in the same directory where we have mounted our project. So we need to know where is the container entry point, as well as what's the path where we're mounting things. And that's where we need to tell make to look. And we can do that with make by saying -c and then specifying the path that it should look in. Okay, so let's walk through this in the demo together now. Okay, so I have the data analysis pipeline software, like the scripts and the makefile, all on my computer. The Docker image has been built on Docker Hub, and now I want to use that Docker image, which is on my computer because I have already pulled it, to run the makefile non-interactively. So how can I do this? So let's give an example. So I'll type pwd to show you that I'm inside of the data analysis pipeline folder. And now I type docker run --rm, again, to make it ephemeral. I skip the -it flag and I type -v. And then I'm going to mount the container here. So we're going to take this current working directory, and I say colon, and then I'm going to put basically create a data analysis EG folder inside of home, inside of our studio in the container. And then what I need to specify next is the image name, which I'm also going to copy and paste to minimize typos here. And then normally we'd be done, but what we're going to do now is specify make all. But make all isn't going to work because the container entry point, when we run this container in basically through the bash shell, is going to be in the root. And that's not where our files go. And why don't we put our files in the root? Well, oftentimes root is a special place on servers and in containers, and you're not necessarily supposed to be or allowed to work there. A better place is to put things in home. So let's tell make that our make file is going to be somewhere else. That's what the -c flag does. And let's say what folder it's going to be in, which is going to be home, RStudio, data analysis EG. Let's see what happens when we run this now. So let's read the output. Make did something, it entered the directory. That's what the -c and then this path does. And then it said nothing to be done for all, probably because the analysis was already run. And then it left the directory, and we're not hanging out here with the Docker prompt anymore. We're back to our bash shell prompt, which means the container closed up and is gone. So let's keep playing with this further. Maybe we can use a similar strategy to make clean. So let's change the target from all to clean. And the same sort of thing happens. Make goes into the right directory. It runs the clean target, and then it leaves and the container shuts down again. And now we can make all again. Or make all this time because it's finally clean as opposed to what it was the first time. So what we can see happening here is this analysis is now running inside of the Docker container, not using the software that's on my laptop. And we're not having to go into the container and type cd here and make all here. We're able to provide one single command, which I'm highlighting right here, that we can give to somebody else. We can say, clone this GitHub repository, install Docker, navigate to the root of the project, and run this command. And then they're able to replicate our analysis. Pretty awesome.